Yes, welcome to this session. I'm Engineer Juma. Taking you through a simplified program on CNC machining mastery. There are key areas or things you need to consider when you are programming your machine, so that you understand what it means. So a CNC in layman language is a computer numerical control. When you say computer, let me just use a simple language. When you say computer, you're meaning computer, it has the power. Computer, you have equal computer, then numerical, then control. This is, it has the memory, the power to input. Maybe it allows you to input, it allows you to process, it can also output data or output information. Then numerical, you're using values, you're using digits, you're using numbers, or let's say digits or numbers. But these numbers are in these different formats. Then control, you can either use PLC way, programmable logic control, to allow the motion. Let me say motion, maybe stepper motors, maybe or servo motors. They are allowing, or even the pump, you are allowing them to move from point A to point B, so that it can do what is required. So in this sense, a computer, you must put information. For when you put information in this computer, it must give you an output. So in simple terms, a CNC, you need to put a program. The program you're using current one, the all language you are using what you call word program. The current one we're using what you call word programming. They were using tab system, but as we're using what programming. I'm not saying we're using Java or C++, but there's a way we introduce what you call G and M codes. So that these G and M codes, they control the movement of the machine from one point to another. So when you are looking at CNC, you are looking at automation of the tool, machine control commands, which is basically allows them to move from point A to point B. And because you're using computers, they're able to execute the predetermined sequence of the movement. These machines are very important. Normally, they are very precise, and they allow repeatability of whatever you want to do. They increase what you call production efficiency. They reduce human error and at the same time labor cost. They can allow you to create what you call on machine complex geometries. As is, it is CNC. Most of these machines are subtractive. Few are additive, like additive machining. When you say subtractive, you are reducing a machine as required. So the CNC has to be configured. You can use a hardware like a controller, motor, drives, feedback system, machine elements. That's you can configure using hardware. You can also configure using software like the CAD design software, CAM software, post-processor simulators together. Then you can also configure using what you call machine components like bar, frame, spindle, turret, tool turret, maybe tailstock, jack, linear axis, all of them. Once they are put together and they're able to move automatically when you put a code, then you have integrated the system to become a CNC machine. But how do you program this machine? As I said, there are various types of machines. You have the CNC laser, you have the CNC plasma, you have the CNC router, you have the CNC lathe. All of them are using the G code, G and M code. But there are things you need to understand when you're programming these machines. So that's why I'm bringing you the fundamental areas that you need to understand when you're using these machines. Maybe we can start some of the key areas you need to understand when you're programming these machines. I want to go direct to objective of today. It is an experiential based training session that we want to understand between the theoretical way and the practical way of colliding or aligning or correlating the CNC machining. And basically, maybe I may use an example of CNC lathe. Also, you need to understand the tool analogy, tool identification, and then you need to understand how you create a practical relationship between the machine and also the user. You need to understand how to select the tools, you need to understand how to select the materials, how to configure the machines, different types of cutting tools, different types of measuring tools, different types of machines, different types of material consumables, CAD software you require, CAM software you require, CNC controllers you require across each one of them. So that when you are programming, either you choose to do manual way of programming or you choose to do CAM way of programming. You are using CAM maybe CAM way of programming, so you also at the same time need to choose the right software for programming. But today we want to basically venture into key areas which is fundamental for our session today. So the fundamental components you need to understand when you're programming is one, the coordinate system. The coordinate system of a machine is very important. Either you are using machine coordinate system, you are using workpiece coordinate system, you are using relative coordinate system, or whichever coordinate system you are using. This is very important for your programming. Another key aspect you need to understand is the axis and the units. Axis and the units. All axes. Which axis is there? Is it a 2 axis? Is it 3 axis? Is it 4 axis? 5 axis? So you need to understand this axis. Then also you need to understand the measurement. Measurement, is it metric system or inch system? For metric system you can use either G21. For inch system you can use either G20. Other machines like Siemens, they can also use G71 for metric and G70 for inches. Then you need to understand the distance or positioning mode or programming mode. You can use either absolute programming or incremental programming. I want to explain these terminologies so that when you are programming, you are able to relate what it means. When I say absolute programming and incremental programming, let me draw a part here. A simple part. Maybe let me change here. Draw. If I have this part, let me use this simple part. This is the center of this part. I can assume this is diameter maybe 30. This is maybe diameter 40. This is where my 0 is. 0 point. When I'm programming, I need to understand where I'm going to clamp my workpiece. Maybe this can be the chuck. This point can be my point of hold the part origin. This can be the part origin. Or what you call the workpiece coordinate system. So I'm using what you call workpiece coordinate system. But machine coordinate system is inside the spindle. So where the spindle is, there's a point where the spindle has what you call machine coordinate system. So they are different. But when you are programming normally, we refer using workpiece coordinate system for CNC lathe, an example, even CNC milling. So in this scenario, I need to understand how am I going to pick various points. Yes, how am I going to pick various points to move from, so that to allow the tool to move from point A to point B. That's why you have what you call absolute programming and incremental programming. Maybe let me finish the theory, then I come there, we explain the difference between absolute programming and incremental programming. So that we use an example for absolute programming and incremental programming. Another key factor you need to consider is also cutting parameters for different materials, either using aluminium, using mild steel, for example, stainless steel, brass, or cast iron. Each one of them have different cutting parameters depending on the tool diameter and also depending on the not the tool diameter but workpiece diameter and also the cutting speed in meters per minute. So you want to check, for example, if I'm using stainless or brass with a cutting speed or at a stroke of maybe 20, if I'm able to calculate, you see it give me this one. So for you to understand this, check on the previous formula. I had given you the formula so that you're able to use this formula to calculate the cutting speed. Another key parameters you need to understand is how can you move, maybe change from cutting speed to spindle speed. I think as I said previously, I gave you a formula. Also, how to calculate the feed rate or the feed. For example, the spindle speed, if you're using a spindle speed, normally this is the formula. You take 1000 times the cutting speed over pi d. Pi d, d is the diameter of the tool, or others using as the diameter of the workpiece. So this is the formula for calculating spindle speed. You can rearrange this mathematically to give you a formula for calculating the cutting speed, which means cutting speed would be equal to 1000 times RPM over pi d, is it? So you rearrange this. Then you need also to understand the depth of cut. The depth of cut, how deep the tool removes the material per pass. Understand the feed, these are the cutting parameters. Understand the cutting speed, VC. Understand the spindle speed. Understand the feed, and understand the depth of cut. So this one is very important. Also, you can calculate the depth of cut for each of the materials. They give you the depth of cut for each of the materials. But when you're using them, it is easier to it will give you the required output. When you are also programming, you need to understand different entities. Like in programming, you have what you call address. A program uses an address. Let me use an example here. It uses an address. Let me go to the second page and we explain what it means by an address. You have a shelf. Yes, you have a shelf. This is a shelf. You have arranged item maybe as per letters. For example, I can say this is my shelf A, B, C, D, E, F, G, maybe H, I, J, K, L, M, N, like that. Yes, so these are my shelf. Maybe these are my shelf. So in this shelf, I may have maybe, for example, G. It has a meaning. In the shelf G, there's a file number 01. There's a file number 02. There's a file number 03. When you're programming, this is the tip. When you're programming, we have what you call a part program. Let me use this one because my handwriting is poor. Let me use this one. You have what you call a part program. Part program. We call them a part program. After part program, we have what you call blocks. Let me arrange them. Blocks. After blocks, we have what you call words. After words, we have these words that are combined by address plus digit. Let me use digit. For example, if I have a value, for example, G01, this G is an address. Yes? G is an address. And 01 is the digit. What does it mean? So when you combine, it gives you a word. But when you combine many words together, they give you block. When you combine a word, it gives you, when you combine an address and a digit, it gives you a word. Yes? But when you combine many words together, they give you blocks. When you combine many blocks together, they give you a part program that is used to cut. So in this sense, let me just write a simple part program. Then I explain the meaning of this part program. For example, let me explain. Write a simple part program. If I can write, for example, O 0 0 0 1. Let me start percentage. For those who are using Fanuc, maybe you can say write 0 0 1 0 0 1, maybe O 0 0 1, T 0 1 1. And say G 0, X 100, Z 100. Example, say G X maybe 42, Z 3, M 08, G 97, M 03, let's say S 600, M 03. Before this one, I can put safety G 54, maybe G 21 first of all, G 54, maybe G 40, G 80, G 95. 5, for example. Then I can now come here and put my program, maybe using G71, maybe U1, R1, again G71, maybe P40, Q maybe 100, U 0.1, or X, then use Fanuc X 0.1, X 0.1, Z 0.1, F 0.2, for example. So this is a simple program. So I can now start my N40, blah blah, N40, write N40, is the 1, X, X, let's say X 30, X 0, can write X is 30, Z minus 20, can come to X is 30, it can go to X 30, Z minus, if I have this part here, we draw this part here, I have this part, this is 30, X 30, that's first point, 30, Z0, then second point here, I have maybe 30, Z minus 20, then it goes to another diameter here, as we continue, this diameter here, I can put maybe 40, maybe Z is minus 20, I can put, then I put N100, G is 1, X is 40, Z is minus 40, for example. Then I can put G70. If I'm using Siemens for, let me put semicolon, G70, and put, for example, G70. After G70, I can put maybe, for example, P40, Q100, and F 0.1. So this is an example of a part program. These are now what we call blocks. These are blocks. These are blocks. In this block, we have in this part program, we have block. This is a block. This is a block. This is a block, and this is a block. So all these are blocks. Maybe we can put this as N1 as the blocks. These are the blocks N1. You can put this as N3. Example, this can be N5. Yes. So this is sequence blocks. So these are the blocks. So in these blocks, each of this block, it has a word. So this is a word. This is a word. This is a word. When you put these words together, they give you a block. But when you put many blocks together, they give you a part program. So this is a part program. We normally call it G and M code. G and M code. In the sense that in this one, we have address. As I said, we have address. A, it may mean axis rotation along x-axis. B may mean maybe axis, for example, normally you have A can stand for maybe rotary, maybe x-axis, this can be x-axis rotation either along A. So along this can be x rotation axis, rotation along A. Along X. Why am I writing along X? Then B can be rotation along Z. Along Y. Then C can be rotation along Z. Then D can denote maybe the tool diameter or tool offset or tool number. Distance can now you have to explain. For example, if I say G00, in each of the addresses, it has from 0, it has from maybe, for example, let me use this one. From each address, it may have from 00 to 9999. So if I am taking 00, the machine go to the address G, it looks at 000 as it was programmed. What does it mean? Then it initiates the parameter. So it tells now that the speed, the motor move faster to this point. Yes, move faster to this point. So this is what it normally does. Move faster to this point. For example, G01, move faster with a cutting speed. This point already cutting speed. It is taking the cutting speed I've put in the parameters. So this is how when you program. This is the language. the example already it is here. You are telling the machine to use this. This is an example, for example. Already you are telling that maybe the program number is this. You are using millimeter. This is millimeter. This is absolute programming. This is cancel any tool radius compensation. Then 54 work offset. Then tool number, tool offset with the M06 means start automatically change the tool to number 1. M03 start the spindle in clockwise direction with a speed of 800 RPM. Then G00 now rapidly move the tool to a safe point, close the workpiece at the meter 80 with the Z5 away from the safety, from the workpiece. Then now start rough turning. For example, if you're using G01, now go to X G01, but now cut because it now require a filtrate. So this is a part program now. You need to understand how to write a program. You need to understand the meaning of each of these code as used in the program. And then these codes, we have codes which are modal, we have codes which are non-modal. Modal codes, they normally stay effective until you deactivate with a non-modal code or with another code. But in non-modal, they remain. For example, if I write here M03, I cannot just come again write M03. This M03 is modal now. It will be used until I initiate with the M04 somewhere. Sorry, with the M05. Now this M03 will stop once I put M05, which means now M05 has deactivated M03, which was modal. The same applies to this G01. Yes, G01 here, it is active. It is active all the way up to here. But because if I have introduced G00, it becomes inactive, which means it has been deactivated by what? The non-modal code G00. Then also, you need to, these are now single blocks. G00, when you're turning, you can use single block. But it may make the program too long. You need to understand the Kane cycle. Kane cycle are pre-built sequence which are normally stored in the controller to automate repetitive operations like drilling, boring, tapping, threading, pocketing, even turning, in the sense that they simplify programming and they reduce errors. This is the purpose of Kane cycle, like G71, G72, G73, G74, like that. Then also, in case you may face challenge of programming this manually, ensure that you integrate your machine with a post processor, with the right post processor, like either using SolidCam, MasterCam, Fusion 360, all of them. And then each of the machine, before you program, take the manual of the machine, understand the meaning of the machine, because each machine has their own meaning. Each machine has a manual with different codes. You need to know the meaning of G00, G01, G02, G03, G20, G21, maybe for example M0. There are normally very many of them. This is just a few of these G and M codes. This is a few of G and M codes. Then also another parameter you need to consider is operations, like facing operations. You need to understand the facing operations. If for turning, straight turning, taper turning, or step turning, taper turning, or internal turning. You need to understand threading operations, internal threading and external threading. You need to understand drilling, how you're going to do drilling for each operations. So these are key areas before you program. Then also, because CNC is a career path, who are you? Are you a CNC programmer? Are you a CNC operator or a machinist? Or are you a CNC technician or the setup guy? For a CNC operator, always the setup, they operate the CNC machine, they load program, they measure the parts, they perform basic machine maintenance. We call them CNC machinists. But CNC part programmer, they only create programs for the from design or blueprints, using the right tool and using the cutting parameters to optimize machining process. So there's a difference between a CNC programmer and a CNC operator or machinist. Then a setup technician prepares the machine for production runs, maybe installs the fixtures, installs the tools, verifies the first part, the quality. That is the work of what? A CNC setup technician. In the job market, normally in Kenya, you can be paid between 98,000 to 106,000 per month, depending on the level of entry and depending on the job. But if maybe you are a CNC machinist, you are a CNC operator, you are a CNC programmer, at the same time you're a technician, you may combine, you may be paid between maybe 250 to 350 or 400 gross salary, depending on the company. Not all of them, depending on the company. Yes, don't say I said you have to pay this because of this. No, depending on the company. But if you're working outside the country, maybe like in US or developed countries, they normally pay between $28 to $45 per hour. So it depends. That's on the higher perspective. Then also as a CNC machinist, understand the axis. We have 2-axis machine and 3-axis machine. We have 4-axis machine, 5-axis machine, turn mill or mill turn. So you need to understand. Even we have what we call multi-spindle machines, twin machines, or Swiss type lathes. So you need to understand which machine you are working on. That is very important. Another aspect you need to understand is on the tool identification and selection. Which kind of the tool code? For example, if I write DNMG 150404 or DNMG 110404 or VNMG 160404, what does it mean? You need to understand the parameter of the insert. You need to understand for example here the CNMG, CCMT, TNMG, DNMG. All of them you need to understand the meaning of these the tools, materials, operations type, sequence, finish requirement, and machine power. You need to understand these factors because they affect this. Then you need to understand the holders, because this tool and insert and holders, they have to collect and match the geometry with the insert size and the geometry to provide the purpose of rigidity and prevent what overhang. Then also understand the minimum quantity lubrication from the coolant strategy. Why is it mist coolant or is it flat coolant? Those are the key areas you need to understand. So the areas that you need to master on as a programmer is practice programming. Write the program for each part and then understand it, simulate it before you cut it. Do a dry run, do a simulation, check that the program is okay. Use a CNC simulator to practice without actual machine. Learn the integration between CAD/CAM softwares. Study the material properties, understand the different types of material properties, and gain hands-on experience so that you acquire these skills. Before you go for interview, ensure you have these skills because they are very relevant. In our next setup, we will come and consider detailed drawing on how to get a program, understanding the coordinate system of each of them, understanding the insert geometry, we will be using a simulator, understanding a sample part drawing, understanding the cutting parameters from combo table, and troubleshooting guide for CNC machines, and also safety protocols on the best practices when you're using these machines. So these are the key areas you as a programmer you need to understand before you start programming. Before you start